In number 10, it says two consecutive terms in a geometric sequence, so now we're going to geometric instead of arithmetic, are given. Write a recursive and explicit function to represent the sequence. So like we did in the last one, I think making a table is going to be the easiest thing for us to do. So let's create that table, and we'll just use our x and our f of x again. And so we have our x value is 3, and our f of x is 16, and that's coming from our very first thing, that f of 3 is equal to 16. X is coming from the inside, 16 is coming from the right. And then we have f of 4 is equal to 32, so we can put in our table that when x is 4, we get 32. And since we know that this is a geometric sequence, it tells us right here in the directions, we're looking at what are we multiplying by each time in order to get from one to the next. So to get from 16 to 32, it looks like we are multiplying by 2 each time. So if we continue to multiply by 2 each time, and we can write this out, so this was 16, this is 16 times 2. If we multiply by 2 again, to get to our fifth term, we would get 64, and we can represent that as 16 times 2 and then times 2 again. And then we also need our sixth term, so we would multiply by 2 again, would give us 128, and representing that, we would have 16 times 2 times 2 and then times 2 again. So if we fill in our answers, f of 5, we can go down to our table. At 5, we get an f of x value of 64. So this would be 64. And then to get f of 6, when we go to our table, when x is 6, f of x is 128. So f of x is going to be equal to 128. So then from here, we can go ahead and write our recursive function. So our recursive function would be f of x equals that previous term, which is f of x minus 1, and then we're multiplying that by 2. And then our first term that we're given here is that f of 3 is equal to 16. And then we need to do our explicit function. So for our explicit function, we can do f of x is equal to what we started with. We started with 16. This time we're multiplying by 2, and we need to know how many times we're multiplying by 2 compared to our x. So we prepared ourselves for that right here. So if we just add to that our number of 2's, we have 0 number of 2's, 1, 2, and 3. So if we look at our x's compared to our number of 3's, you can see that it is 3 less than what we wanted to start with. So then we could say that this is 2 to the x minus 3.